are the area formulas? Because today we're going to be talking about surface area. Surface area still heavily relies on the idea of calculating for the area. So I want you guys to take a screenshot of all of these area formulas because we are going to need them. We're going to need them. So I'm going to give everybody 5 seconds to take a picture of these or to take a screenshot or to quickly. I'm happy to do that, Sanele, if you can stay behind a couple more minutes. Okay. All right. If you can stay behind, then I'm happy to do that. Okay. Oh, yes, I remember, Abu. We also did that in EGD as well when I was in school. All right, lovely. Okay, so I want us to note here that surface area is mainly calculated for 3D shapes. Okay, it's only 3D shapes. If it was a 2D shape, we would then just calculate for the area. So there'd be no need for us to look at it as surface area. We would just look at it as area. So when it comes to 2D shapes, we calculate area. When it comes to 3D shapes, we calculate for surface area. And when we calculate for surface area for 3D shapes, what we need to consider is the faces of a shape. The faces of a shape. All right. So let's look at this shape that I've got down here. This is called a what? What kind of shape is this? This top shape here. What do we call it in mathematics? Or in general, what kind of shape is it called? What is that shape called? A long cube. No, it's not called a long cube. No, absolutely not. Thank you, Didi Malo. It's called a rectangular prism. That's correct. This is called a rectangular prism. A rectangular prism. All right. Okay, so when we calculate for a rectangular prism, it's kind of like looking at a box and kind of breaking the box apart. All right, so we're looking at the top part, or let's start with the front. So I know that I've got the front part of my box or my rectangular prism. I've also got the top part of my rectangular prism, and I've got the side of my rectangular prism, the side of my rectangular prism, right? But the reason why I'm only highlighting those three is because I know that if I have a front part, the front part looks exactly like the back, right? If I have the top part looks exactly like the bottom. And if I have the right-hand side looks exactly like the left-hand side. Thumbs up. Are we all in agreement here? Is everyone with me? Yes? Lovely. Okay. So we know that each of those will be the same thing. Now, if I had to break this apart, if I had to break my box into bits and pieces, I know that if this is the front, if this is my front, then my front will be connected to the top. Oh, sorry, I used the wrong color. Let's erase that and start again. I know that my front part, the front will be connected to the top, which is then connected to the back. The front is connected to the top, which is connected to the back. I also know that the front is also connected to the bottom, and that's what we've got over here. All right, and then I know that the front will also be connected to my right-hand side and to my left-hand side. So I know I can kind of tell that my box has been drawn or has been made up in symmetry. It's kind of built symmetrically. All right, so if I want to calculate the surface area, we don't just call it the surface area, we call it the total surface area, because what I'm going to have to do is I'm going to have to calculate the area of each surface, and I'm going to add them together. So total surface area is TSA. We denote total surface area as TSA. Thumbs up. Are we all okay? All right, that's what it's called, TSA. Lovely. So let's actually look at an example. Let's see what we'd have to do in order to calculate for this rectangular prism. Okay, so you'll see that they haven't given us all the dimensions. They've only given us some of them. But we know that because this thing is built in symmetry, some of these things are also going to apply to other sides. Okay, let's start with this 5 centimeters. I know that this 5 centimeters is the breadth of my front rectangle, right? But I know that if this side is equal to 5 centimeters, that means this top part over here is also 5 centimeters. Thumbs up. Are we all in agreement? Yes. Amazing. Good. If this part is 5 centimeters, that means that part over there is also 5 centimeters, which means that this side at the back over there is also 5 centimeters. So we can tell which sides are equal to 5 centimeters by looking at the symmetry of our box. All right. Then I know that if this side is 3 centimeters, that means this top part over here also 3 centimeters. That part over there also 3 centimeters. And that bottom part over there also 3 centimeters. Okay. If this part is 4 centimeters, I know that this part over here is also 4 centimeters. I know that this part over here is also 4 centimeters. And I know that that back part over there also 4 centimeters. All right, so we can kind of follow each of the sides as we're going along. All right, so if we break this thing apart, do we notice that all the 5s almost go like around my box in a circle? Let me show you what I mean. This is 5 centimeter, 5 centimeters, 5 centimeters. Do you see how it looks like they go around my box? Yes? Okay. Good. So that means if I unpack my box, all of the 5 centimeter sides must follow each other. They must all follow each other. Okay, no worries. No worries, Iketelo. That's fine. No worries. Welcome. It's lovely to have you with us. All right, so I know that if this side is 5 centimeters, the 5 centimeters need to follow each other around my shape. So 5 centimeters, that will also be 5 centimeters, 5 centimeters, 5 centimeters, 5 centimeters. Thumbs up. Everybody agree with me? Are we all okay here? Amazing, 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 amazing. All right, okay. Let's talk about the 3 centimeters. Let's look at all the 3 centimeters. I'll change colors here. Right. So there we go. We've got 3 centimeters, 3 centimeters, 3 centimeters, 3 centimeters. So these 3 centimeters need to follow each other around the shape in that direction. Right. So I know that if this side over here is 3 centimeters, the 3 centimeters need to follow each other around. So this side will be 3, this side will be 3, and that side will be 3. All right. Okay, and we can tell that they follow each other around the shape. Now, the others are the 4 centimeters, and these are a little bit sporadic. Okay, because I've got 4 centimeters here, 4 centimeters there, 4 centimeters, 4 centimeters there. So they need to follow each other around the shape like that, right? But because my shape has been broken up using the side pieces, I know that wherever there's a 3, there must be a 4, right, on the sides. Wherever there's a 3, there must be a 4 on the sides. And over here, I see a 3. So next to the 3, there must be a 4. Next to the 3, there must be a 4. And the other 4s are over here next to the 5s. So wherever there's 5s elsewhere, we also need a 4. So there's a 5, so we need a 4 there. There's a 5, and we need a 4 there. All right. Does everybody understand what ma'am has just done? Are we all kind of like okay with where ma'am has gone with this? Lovely. Okay. All right. Amazing. So I'm just going to name these. I'm just going to number them so that we don't get lost. I'm sorry, not number, name them. Okay, I'm going to remove the values because all the values are sitting on our net. Okay, so if the values are sitting on the net, we know exactly where they are. Now, if I've got the front part, I've said that the front part is 5 centimeters by 4 centimeters. I know that the front part needs to be the same as the back part, as the back. I think have I made a mistake somewhere? Yes, I have. This is not 3. And this is not 4. This should be 3 centimeters. Sorry, guys. 3, 4, 3. That's it. 3 centimeters. Okay, we've missed one. Yes, 1, 2, 3, fourth one over there. Let me make this 3. Sorry, guys, I missed it there. That one should also be 3 centimeters. So I know that the front, which is 5 by 4, should be the same as the back, which is also 5 by 4. So I know that this will be the front part, because that's 5 by 4, and that will be the same as the back part, which is also 5 by 4. Okay, now, if I look at the top part, the top, I know that the top needs to look like the bottom part. And the bottom part and the top part are both 5 by 3. Now, I can see that this middle one over here, that is the 5. So I'm going to name that the top 5 by 3. And this bottom one over here, the bottom 5 by 3. All right. And then we've got the sides, which are 3 by 4. And the other side will also be 3 by 4. So this is the right-hand side. So I know that the right-hand side is 3 by 4, just like the left-hand side is 3 by 4. All right. So if we calculate for the total surface area, TSA is equal to, what we would have to do is we would have to take the area of the front plus the area of the top plus the area of the back, plus the area of the bottom, plus the area of the left, plus the area of the right. But what we know is that the front looks exactly like the back. So instead of calculating each of them separately, what we can do is we can take the area of the front and we can times it by 2. And that covers the front and the back. Thumbs up. Does that make sense? Then I don't have to do the same calculation twice. I can just do it once, calculate the front and the back, the front times 2, and that covers the front and the back. Same with the top. I know that I can just add the area of the top, and I know that if I calculate the area of the top, I've also calculated the area of the bottom. So the area of the top times 2 takes care of the top and the bottom, plus the area of the left-hand side, times 2 takes care of the left-hand side and the right-hand side. Okay. And then we can calculate using that. So let's put all of these together. Now, all of these, because this is a rectangular prism, this is made of rectangles. So we need to know the area of a rectangle in order to calculate for this. And we know that the area of a rectangle is length times breadth. All right. So if we want the total surface area, the area of the front is going to be the length is 5 times the breadth, which is 4. So 5 times 4 times 2, close brackets, plus the area of the top. We've got here that the top is 5 times 3. So 5 times 3 times 2, plus the area of the left-hand side, which is 4 by 3. So we'll have 4 times 3 times 2. And we can punch that into our calculator and get an answer. We don't actually have to calculate this. And unfortunately, Abu, nobody's going to label anything for you. You must label all the sides for yourself. Sorry for you. Sorry. All right. So we're going to get 5 times 4 times 2. That's 40 plus 30 plus 24, which is equal to 94 centimeters squared. Now remember, it is an area. Even though it's surface area, it's still an area. So our answer must come in centimeters squared. Nope, they don't do that either, Abu. Sorry. You need to do that for yourself. All right, thumbs up. Does everybody understand the process that ma'am has just gone through? Are we all good? All right. Okay, let's look at a different shape. Let's look at this shape over here. Okay, I actually want to get rid of something. Give me a second. Okay, I want to get rid of this. All right, what do we call this shape? What is the shape called? It's a slide. It's not a rectangular prism. It's not a slide. What shapes is it made of? What shapes is it made of, peeps? Right, they are 3D right angle. That's it. It's made up of triangles. Therefore, it is a triangular prism. Lovely. Well done. A triangular prism. And the reason why I'm emphasizing the names of these shapes so much is because sometimes in a question, they'll just say a triangular prism with sides, and then they don't actually tell you what a triangular prism looks like. And you need to figure that out for yourself. So it's quite important that we know what we're looking at. All right. Okay. So let's look at this over here. I know that if I want to calculate the total surface area of my triangular prism, I'm going to have to break it up into its parts. Okay, so I can tell that this particular shape is made up of a triangle over here. So there's a front triangle and there's a back triangle. So front and back. And these two are exactly the same. But it's unfortunate. Those are the only two things that are the same. Do we agree? Yes? Those are the only two things that are the same. Tidimalo, when you say no, where did I lose you? Which other part is going to be equal to another? I'm going to show you why they're not equal to each other in just a second. All right, so if we break this thing apart, let's break it apart like we did the other one. Okay, first thing we're going to note is that there's a rectangle at the very bottom, right? So I'm going to draw the bottom rectangle like that. There it is. I can tell that the dimensions of this rectangle, the long side is 8 centimeters. 8 centimeters, and this side over here is 3 centimeters. Now, this 3 centimeters is connected to my two triangles on either side, because if this side is 3 centimeters, that side is also 3 centimeters. So on each of these sides, so here, there will be a 3 centimeter triangle, and they've told me here that it's right angled. And on this side, there will also be a 3 centimeter triangle. Sorry, sure. My drawing is shocking. There we go. I tried. And we know that this side is also 3 centimeters. We've been told that the other side of our triangle is 4 centimeters, which means this side over here, the straight edge, will be 4 centimeters. This is a right angle triangle. This is also 4 centimeters. Now, connected to the 4 centimeters is going to be that back part over there. And I don't know what happened here that we are now. Okay, there's a reason why I don't want that there. All right, so I now know that at the back there, there's another rectangle there. It's connected to the 8 centimeter side and to the 4 centimeter side. But we've moved the 4 centimeter side over to the side. So we're going to connect it to just the 8 centimeter side. Okay, we're going to connect it like this. But we know that this side over here is 8 centimeters. This side over here is also 8 centimeters, because technically we are going around in a circle with your 8 centimeter, 8 centimeter, 8 centimeter. We're going around the shape. Okay, so 8 centimeter, 8 centimeter, 8 centimeter. Okay, we're going to add another one in just a little bit because there's actually 4 of them. I'll show you just now. All right, so if that's 8 centimeters, I know that this 4 centimeter side is actually connected to this part over there, and this side is connected to this part over there. So this side, look now what Teacher Coco has done. This side is also 4 centimeters, and this side over here is also 4 centimeters, because it's kind of like we've broken it apart, and those two sides that used to be together are not. All right, so we've now covered, I need to be very careful here. We've now covered the bottom rectangle we've covered the side triangles, and we've covered the back rectangle. Okay, the only thing that's missing is the top rectangle. This one over here, this top one. All right, thumbs up. Everybody with me there? Yes, I think you liked it better in 3D. So there's a top triangle as well, right? But if we look at the top triangle, I'm going to add it in here, right? Sorry, not triangle, sorry, rectangle. The top rectangle, this one up top here. Right? We know that the length of that rectangle is also, we know that it's 8 centimeters. However, that's the length of the rectangle. It's going to be 8 centimeters. We can tell that because it's connected to that 8 centimeters over there. The only thing we're not going to be able to find, which I keep putting back in every single time, is this length over here. Is this length over here. And the way we can calculate for this length in a right angled triangle, this is what Teacher Coco was getting at, even though every single time I tried, the answer kept popping up. How are we going to use, because I now know that I need to find the length of this side over here. How can I use these two to find the length of that side? We all know that it's 5 centimeters, but how am I going to use it? Exactly. We're going to use Pythag, or as Narisha says, Pythag. You know what I mean? Pythag. I like it. Okay, we're going to use Pythagoras. So wherever we see a right-angled triangle, we can use Pythagoras to find the other side. So we can do that. We can say that the hypotenuse is equal to the square root of 4 squared plus 3 squared. And we know that 4 squared is 16 plus 3 squared, which is 9. 4 squared, 16 plus 9 is 25. The square root of 25 will give us 5 centimeters. And ta-da, there we go. The answer would be 5 centimeters. Okay, they don't always give us that side. So now we know that this last triangle over here would be 5 centimeters. Now, I want us to note, grade 10s, that every single one of these rectangles is 100% different. Let's look at it. This one is an 8 by 3 rectangle. This one from the bottom or from the back is an 8 by 4 rectangle. And the one at the top is an 8 by 5 rectangle. Thumbs up. Are we making sense? Everybody with me here? Oh, yes, 8 by 3, 8 by 4, 8 by 5. That's it. The only two things that are exactly the same are my two triangles, right? That triangle and that triangle. Those two, the same. So if we want to calculate for the area of the two triangles, we can just calculate for the area of one triangle and multiply that by 2. All right, let's talk about the total surface area. Now, we need two things. We are going to need the area, not too far. We're going to need the area of a rectangle. Area is equal to length times breadth. And we're going to need the area of a triangle. And we know that the area of a triangle is half base times perpendicular height, which we have in this case. All right, so let's look at TSA. The total surface area. So we're going to go total surface area equals. Let's start with the triangles because they're easiest. So we will go half of my base, which is 4, times my perpendicular height, which is 3. And we're going to multiply that by 2 because there's 2 of them. Okay, and then to that, we're going to add the sides, plus the rectangle of each side, plus 8 times 3, first triangle, plus second triangle, 8 times 4, plus third triangle, not times, plus third triangle, 8 by 5. Okay, and then we add all of those together, and we can do that in a calculator. All right, so I know half of 4, that's 2. 2 times 3 is 6, times 2 is 12. 12 plus 24 plus 32 plus 14. And we can just put all of those together and get an answer there. What would my answer be? 108 what? Abu, 108 what? Centimeters. Again, a surface area is still area, so centimeters squared. Lovely. All right, thumbs up. How are we feeling about this? Are we doing okay, guys? Yes, it's a lot of work. It requires us to think of shapes, break them apart, put them back together, make sure that we're doing the right things in each of those. Okay. Exactly. Oh, you missed the 30. See what I mean, Abu? And now it's haunting you, even in grade 10. Asanda, unfortunately, not for composite shapes. We call, or sorry, not for this particular idea. Okay. In this idea, you need to just break each shape up into its parts and then calculate the area of each part separately, because we know the formula for the area of a rectangle, we know the formula for the area of a triangle, and so on and so forth. Okay. All right. I'm going to give you guys a chance to do a particular question all your own. I'm just going to down. Okay. I want everybody to calculate the total surface area of this first shape. This shape over here. I'm going to name it number 1. Okay, let's everybody calculate the total surface area of this rectangular prism. Pop your answers in the chat when you're ready. I see 2 people are done. Let's see if everybody else can get there. Sanel is also done. That's lovely. Narisha's also done. Okay, this is great. Okay. I'll give everybody else 1 more minute. Actually, you've got 30 seconds, and then we'll start looking at the question. Let me just close this up. We're going to use this next. All right, that's time. Let's have a look at the answer. Okay, so again, not that big, Narisha, but let's see. Let's see. All right. So I know that in this first shape over here, I've got a rectangular prism, so the top part will be exactly equal to the bottom part. I know that the front part will be exactly equal to the back part, and I know that the side will equal the side. Right. The side will equal the side. So I just need to figure out the dimensions of each of them so that I can do that, because I know then I can just multiply each of them by 2. All right, so let's start with the top. Let's start with the top. I know that if this is 6, this is also 6 centimeters, and that takes care of my top. So my total surface area for the top is going to be 7 times 6, but that's the top and the bottom, so times 2. Right, that's the top. This right there, top, right, plus, let's look at the front. If we look at the front, I know the dimensions. If this is 3, this over here is 7 centimeters, and that takes care of that. I'm going to take 7 times 3 times 2, and that takes care of the front and the back. And then I'm just going to do the side over here, the side one plus the side. That's going to give me 6 times 3 times 2. All right, if we put all of these together, 42. Oh, yes, Narisha, you're absolutely correct. This number should be really big. 42 times 2 will give us 84, plus 7 times 3 is 21, plus 2 times 2 is 42, plus 6 times 3 is 18, times 2 is 36. So it should be quite the big number, right? So 84 plus 40, that's 126. 162, correct. No, you're spot on, Abu. 162 centimeters squared. All right, everybody happy? Yes, did we manage? Yes, did we do well? Amazing, amazing. All right, let's look at this next one, because this next one is called a what? What do we call number 2? What shape is this? A wheel? It's not a wheel. It's not a wheel. What is it? That's it. It's a cylinder. Thank you, Didi Malo. It's a cylinder. A wheel. A square. I saw somebody say a square prison instead of prism, but I love it. I'm here for it. Okay, okay, let's look at number 2. Now, I want us to take a bit of a moment to understand exactly what's happening with this one. All right, so I've got here a bottle, right? Normal bottle, we've all got one of these. It's like a water bottle that you can carry fancy stuff in, right? Now, if I wanted to make a label for this bottle, I know that labels come as rectangles. Thumbs up. This is a true statement? Yes, labels are rectangular. Okay, and now if you're still a bit confused as to why they're rectangular, I'll show you. If I've got my box and I want to make a label for my box, I need this whole part of my box to be covered like this. And so this is going to be covered by the rectangle. Do you see that? I just need to take the rectangle and wrap it around my cylinder. Is that okay, Narisha? Are we okay with that idea? Yes? Okay, lovely. Okay, so if I had to break up this rectangle, this cylinder, now I'm calling it a rectangular prism, I would do this. I know that I have a circle on the top and I have a circle on the bottom. So I will get a circle and a circle. Let me move up a little bit, move down rather. Okay. Trying to get as much space as I can here. All right, I'll get a circle at the top and a circle at the bottom. Now, I know that if I were to make a label for the middle part, the label on this side, the thing that goes around, would be a rectangle. It would be a rectangle. Now, I know that the rectangle is easy enough. I know that the breadth or the side from there to there would be 5 centimeters. The side in between my two circles would be 5 centimeters. 5 centimeters, right? Now, the thing that's really, really troubling me is the length. because I can't see the length from my cylinder. I can't really see it. But if we look at the idea of this rectangle, I know that the rectangle starts at a particular point. If I'm making a label, the point, this starts at a particular point, and my label would go around, let me use this side round. My label would go around the shape like that, right? But it's going around the edge of my shape. The label would go around the edge of my shape. That's it, Abu. What do we call the edge of a circle? That edge of a circle is called the circumference. Thumbs up. Everybody with me? That's it. The perimeter of my circle, which is the circumference, is the length of my rectangle. All right. So we know that going around the shape, the length will equal the circumference, which is the same thing as the pi times the diameter. All right. Is anybody confused? Do I need to re-explain? Are we all good? I'm hoping everybody is okay. All right. Pies are tasty. Pies are tasty. Yes, Abu, that's fine too. That's perfectly fine. It doesn't matter how you spell it as long as you use it correctly and you eat it correctly. You know what I mean? All right. Okay, cool. Okay, so we now know that if we want to calculate for this, remember guys, this question says calculate the surface area in centimeters squared. So we can't use this 90 millimeters. We're going to have to convert that into centimeters. I'm not going to belabor this. I think we're all in grade 10. We know how to convert from millimeters to centimeters. Yes. Yes, we're just going to take that number and divide by 10. So 90 millimeters is the same as 9 centimeters. Now, my diameter of my circle is 9 centimeters. Okay, but if I want to calculate for the area of my two circles, I know that the formula for area is going to equal pi times the radius squared. Okay. All right, so pi times the radius squared. So let's put these two together to figure out the total surface area, TSA. Sorry, I forgot to write here. Our diameter equals 9 centimeters. Okay. Sorry, guys. I feel like there's something outside my window and I'm so freaked out. Okay, so total surface area. We're going to take the area of my rectangle, of my circle, and I'm going to times them by 2. I have two circles, one at the top, one at the bottom. So I'm going to go the area of my circle, which is pi times. Now, if my diameter is 9 centimeters, I know that my radius is going to be half exactly as under half of my diameter. So my radius is going to be 4,5 centimeters. So pi times 4,5 centimeters squared times 2 for the circle at the top and the circle at the bottom. And to this, we're going to add plus the area of the rectangle in the middle. So we're going to take the circumference, which is the length. So pi times the diameter, which is 9, that's the length, times the breadth, which is 5 centimeters. All right, and we're going to punch that into the calculator. Somebody give me an answer. Give me. Sure, guys, please. Oh, Abu, do it again. Somebody give me the answer. Pi times 4,5 squared times 2 plus pi times 9 times 5 equals. Okay, I get a very ugly answer, but it's okay. It's the correct answer. Even if it's ugly, it's the correct answer. So let's do it to 2 decimal places. The answer I should get is indeed 268,61 centimeters squared. All right. All right, grade 10s. How are we feeling about this? Triangle wrong. That's okay, Sanela. Beautiful work. Okay, so here's the thing. Grade 10s. What I've done today is grade 9 work. I've only done grade 9 work. Okay. I'm going to leave you guys with some examples to go and try. You can take screenshots of those. Let's take a screenshot of this. Calculate the total surface area of this composite shape. Okay. I need you guys to learn how to do this. I'm going to give you guys like 5-10 seconds to take a screenshot. Right. 4, 3, 2, 1. And we need to calculate the surface area of that one. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and there's your last screenshot. The reason why I need us to be really okay with these questions is because the questions that we're going to be doing on Wednesday on total surface area, some may or may not involve X and Y. So I need us to be okay with doing the number stuff so that when ma'am adds X and Y, we are not like, oh my gosh, what is this woman doing? We need to be okay with this stuff so that when we do the other stuff, we are okay with that. All right. And with that, I'm going to end today's lesson. I'm sorry, guys. What I'm going to do is I'm quickly going to set up the post on how to set up your exam timetable. Okay. I'm doing it as we speak so that I don't forget. So I'm going to link it quickly to this particular post, and then the post that I'm putting up, and then you guys will be able to watch the TikTok, and the TikTok will help you figure out how to set up your exam timetable. All right. That being said,